All right, so on this one here, okay, we got plane lands on a runway at a velocity of 200 meters per second. What is that likely to be as a given?
Velocity.
Initial velocity, yeah. Okay, sounds like where the question is starting. So 200 meters per second. Over a 15-second interval, what did they just tell me? Time. Okay, it slows at 6.5 meters per second squared. Positive or negative? Negative. That's the trick with this question. Okay, if it's slowing down, that means that the acceleration and the velocities are in opposite directions. Okay, what is the final velocity of the plane? So we're looking for VF here. All right, so we got A equals VF minus VI over T. What should I move first? T, yeah, multiply both sides by T. Okay, so A times T equals VF minus VI. What do I do with VI? Add it to the other side, right? Do the opposite. So VI plus A times T. All right, now we can plug in our numbers here. So we're going to have 200 plus negative 6.5 times 15 seconds. Sorry, forgot to fire up my calculator. What does that come up to?
102.5.
102.5?
Positive.
Positive 102, okay, 0.5 meters per second. Okay, if you forgot the positive, would you get it wrong on a test?
Yes.
Yes, you would. Okay. All right, is that making sense? Okay, so are there little contextual tricks within the questions? Yeah, okay, and those are the things that catch people. Now, if you missed that, you could still get 3 out of 5, okay, if you show your work. You're going to get the 8, you're going to get the givens, you're going to get the formula, and you're going to get the manipulation. You're just not going to plug in the right numbers or get the right answer. Okay, so always make sure you show your work. Okay, and I'm saying this because I had a person on Friday ask me, not this class, ask me, Mr. Coderre, do I need to show my work? And I said, no, but you should, because if you get the answer wrong, what can I give you? And he says to me, nothing, and then promptly doesn't show any work. So, show your work is the moral of the story, okay? Because you can get part marks for it if you something simple, you just mess up punching it in your calculator. That happens all the time, okay? You can still get 4 out of 5 if that happens, if you've shown all your work. Okay. This one seems like it doesn't give you very much information. But again, the context of the question does. I'll give you a few minutes on this one. All right, what are the 2 contextual tricks in this question? If it falls off of a cliff, how fast is it moving initially? 0. It wasn't thrown, okay, it just fell. If it fell, if something just falls, or is dropped, or something like that, then the initial velocity is 0. Okay, so that's one contextual trick within the question. What's the other one?
On Earth, gravity has a force of 9.81 meters per second.
An acceleration, yes, of 9.81 meters per second squared. Okay, so the other thing is it's falling, and on Earth, all things fall at 9.81 meters per second squared down. Okay, so we also know the acceleration to be this. Okay, they tell us the final velocity is 42 meters per second, and that's down. Okay, although it says speed, so we can't really put that on there. We know it would be moving down, but we can't put it on there. And we're looking for time. How long did it fall for? Okay, so those are our givens. Okay, we know it's an acceleration problem because of the things that we were given, and we're trying to solve for t. So what should I do with t? Multiply it over to the other side. Okay, and then what do I do with a? Divide it over to the other side. Okay, so t is going to equal Vf minus Vi over a. So that's going to be 42 minus 0 divided by 9.81. And I'm not going to put negative on that, okay? Because in this situation, it's kind of a third contextual trick. I know the acceleration and the movement are in the same direction. Question?
A question like that, like on a test?
Oh, absolutely. Yeah.
So, like, need to know what the route.
Well, it's on your formula sheet, so you don't have to memorize it. You just need to know that it's on there. I mean, you're gonna use it so much that you will just end up knowing it, but.
Would you get that wrong if you put the negatives?
Well, if you made this negative and this negative, you'd still end up with a positive number for time,
Yes.
right? But if you don't put it in there, you're gonna get a negative number for time, which means that by falling off the cliff, the rock went back in time. Okay, so unless there's some sort of weird portal there in the cliff, that's not happening. So just know that if that happened, you'd have to go, oh, right, one of those, I was dealing with scalar quantities, so I didn't have to worry about that. Okay, so we'll have 42 divided by 9.81. Okay, so we're looking at 4.28 seconds is how long it would fall for. Okay. Guys, they honestly don't get much more difficult than these kinds of questions. I mean, it's just algebra. It's always the same kind of algebra. The only way I can make these questions tricky is I can't really make them difficult. I can only make them tricky. And that's by putting in weird contextual tricks into the question. Okay? Questions on number 2?
On a test, if we didn't put the direction that it's accelerating in, would we lose a mark or?
If it mattered for the question, yes.
Okay.
Okay, in this case, I put down, because I automatically, if I know it's a vector quantity, put a vector on it. But because it said it reaches a speed of 42, and I was looking for time, which is also scalar, I knew direction wasn't gonna matter here. Okay, try that one. That's the trickiest of the manipulations. Yeah.
On the last one, there's a 42 and 9.81 negatives, it's going down.
Again, we don't have to make them negative because they were in the same direction. It didn't change directions, and they told me the 42 is a speed, which means it doesn't have a vector. I know it's down, but it wasn't given to me. All right, so we're looking for the acceleration on this one, so that should make it a bit easier. Maybe we don't have to do any algebra. That runs out of gas while moving up a hill at 6.5 meters per second. Okay, this feels like a question where the direction might change, so I'm going to indicate that up the hill is positive and down the hill is negative. Okay, so initial velocity is positive 6.5 meters per second. Okay, rolls for 8.2 seconds, 8.52 seconds. Okay, and its final velocity is 3.78 meters per second down the hill. So I'm going to make that one negative. Okay, so A is going to equal VF minus VI over T. Okay, so we'll have negative 3.78 minus 6.5, positive 6.5, and then divide that by by 8.52. That's scalar, so that can't be negative. All right, am I going to get a negative number on the top here? And should I? I definitely should. Okay, the change in velocity is completely negative. So negative 3.78 minus 6.5. And it gives me a change in velocity of negative 10.28 meters per second. Divide that by the time, 8.52 seconds. And I get negative 1.21 meters per second squared. Now, do I leave it as negative? No. What do I make it? Downhill, not down. Remember, down is through the hill. Okay, this is down the hill. Okay, so we take out the negative and like what we were given in the question. Okay, so again, that one mathematically isn't challenging at all, but contextually, I got to remember things like it's negative. I got to remember my vector, final vector needs to be down the hill and not negative. Just little things that you always have to be aware of. Okay, I'm going to give you guys about a 5-minute break here, okay, within the classroom, and then I'm going to have you work on a couple of other ones off of the worksheets, and then we're done with acceleration today. We're moving on to work energy here tomorrow. Okay, all right, so 5-minute break here, guys, and then we'll pick up where we left off. Okay, this week's quiz is just on acceleration, okay, because I'm just gonna start work energy theorem tomorrow. So, yeah, we won't have a quiz on work energy theorem until next week, but this week's will be on acceleration. That's quizzes, practice quizzes 8 and 9. And if you really want an extra question, the first question of quiz 10, but that is like, it's got a little bit of work energy theorem in it. So 8 and 9 for sure are just acceleration ones that you can have a look at. Fine stuff.